Hello, pre-algebra students. We're going to be talking about solving one-step equations today. An equation is a mathematical sentence that contains an equal sign. So, yesterday's lesson we talked about algebraic expressions, whether that be a one-term expression called a monomial or a two-term binomial, three-term trinomial. Those were all expressions. They did not have equal signs. So an equation is a sentence, a mathematical sentence that contains an equal sign and is a statement that shows two expressions are equal to each other. Okay, saying that two things are equal to each other. The value of a variable that makes the equation true is called the solution. Now remember, you'll simplify expressions. That's what we were doing yesterday. Simplify expressions, but you solve equations. Okay, so listen to that. That's two different things. You simplify expressions, but you solve equations. So a simplified expression could have two terms in it, but a solved equation, you'll find the variable x, y, z to equal a number. So that is the difference. So find the solution of each of these equations. Well, let's see. What plus 5 equals 6? Well, 1. So x here is 1. What minus 2 equals 4? 6 minus 2 equals 4, so x must be 6. X plus what? What plus 1 equals negative 2? What plus 1 would equal negative 2? That one's a little bit harder to think about. It needs to be negative because we're going to keep the sign of the larger number, so that must mean it's negative 3, because negative 3 plus 1, you would subtract and keep the negative. Alright, 2 times what number plus 3 equals 9? Well, 6 plus 3 equals 9, so what do I need to multiply 2 by to get 6? I need to multiply by 3. So I solved all of those equations just looking at the expressions. Solving an equation by just looking at it to figure out the solution, that is called solving by inspection. Just sitting and thinking about what would work. And this is fine for simple equations like those that I just showed you. But think about this equation. Look at this. 2 times x plus 2 minus 3x plus 36 equals 4x plus 6 minus 48 times x plus 3. Okay, now so I've said here that that would be impossible to solve by inspection. I don't know if the word impossible is the right word there, but it would take us a very long time. So we do have another method, and this is called solving by using inverse operations. Now what are our operations? Our operations, like the order of operations, is multiplying, dividing, adding, subtracting. So what's the inverse? The inverse of addition would be subtraction. What's the inverse of subtraction? The inverse of subtraction would be addition. So you'll notice my arrows go both ways. What's the inverse of multiplication? Well, of course, that's division. And what's the inverse of division? That's going to be multiplication. So you're undoing what has happened to the variable to solve for x or y or z. Okay? The idea is to undo what has happened. So for example, if I start at a number and subtract 5, then add 5 back, wouldn't I end up with the original number? So let's make that number x. So if I have x and I subtract 5 from x, but then I decide to add 5 back, the two 5's here, a negative 5 plus 5, that's going to turn out to be 0. So I'm right back where I started with x. So whenever you undo what's happening, you isolate your variable. You get your variable to be left alone. And it also works with division. If I divide by 2 and then I multiply by 2, so let's say x divided by 2, and then we're going to multiply times 2. Well, now we've already talked about multiplying fractions. The 2's understood over 1. Your 2's, it'll be 2x over 2. Your 2's cancel out. They have a value of 1, so I'm left with 1x. So again, we undid. If you've been dividing and you multiply, they cancel each other out. Alright? This is called the golden rule of algebra. Highlight, you might even want to highlight the whole box. The idea is whatever you do to one side of an equation, you must do to the other. Otherwise, the two sides will not remain equal. We want to keep the two sides equal. It's kind of like a teeter-totter. If we want to keep them balanced, if I've added something here, then I must add it over here in order to balance out the teeter-totter, to keep everything even. If I subtract something over here, then you must subtract from the other side to keep it even or equal or balanced. So let's look at some examples. They're telling me here that these two expressions are equal, and you know I have to believe them because they've given it to me as fact. Whatever x was plus 5, it was equal to 6. Now I can solve this by inspection. I think x is 1. But let's don't just trust inspection. Let's follow the golden rule of algebra. So here we have x having a 5 added to it. I'm going to use the inverse operation and undo what is happening to x by subtracting 5. Well, the golden rule says whatever you do to one side of an equation, you must do to the other. Otherwise, your teeter-totter is going to get off balance. So when I subtracted 5, I undid what had happened to x, and now I have just x. And when I say 6 minus 5, because I have to do the same thing to the right side of the equation, I end up with 1. So my guess, or my inspection answer, was correct. So see how it takes all the guesswork out of it? If I'm subtracting 2, I need to add 2 to undo what's happening to x. So I'll add 2 to the other side, and then the 2's cancel, and x is going to equal 4 plus 2 is 6. Okay, you get the hang of it? So here I have x plus 1. I need to subtract 1. This will be on the back of your paper. And x will be, now here's where those integers, now do you see why we had to spend so much time on adding and subtracting integers? We're solving for x, and in order to do that I have to know that a negative 2 minus 1 is the same thing as plus a negative 1, and so I end up with negative 3. Be careful with all of your signs. Alright, I've accidentally slipped a two-step equation in here, so stay tuned. I'll show you how to do that on the next or an up-and-coming video soon. Remember that the solution is the number that makes the equation true. So we can always check our solutions by plugging them back into the equation. So let's look at these examples where they ask us to solve each equation and then check our solution. So here I'm going to add 4 to undo what happens to x. And I have to do the same thing to both sides. So a negative 3 plus 4, those are integers with opposite signs, so I'll subtract and keep the sign of the larger. So I'm going to come over to the right and I'm going to check to see if that's true. So in place of x, I'm going to plug in 1. Notice how I put parentheses. I'm hugging my variable where x was, and now I replaced it, substituted in a 1. And I'm checking to see, does that equal a negative 3? Well, 1 minus 4, opposite signs. It's like saying plus a negative 4. Opposite signs, so I subtract and keep the sign of the larger. And negative 3 does equal negative 3, so cha-ching, that checks out. Okay, let's subtract 6.8. Now be careful, line up those decimals, subtracting 6.8 from both sides. So x equals, and that's going to be a negative answer, That's going to be a negative 2.6. 2 from 8 is 6 and 4 from 6 is 2, but I keep the sign of the larger. And I need to check. So I'll say negative 2.6 in place of x plus 6.8. Does that equal 4.2? And since they're opposite signs, I'll subtract 6 from 8 is 2, 2 from 6 is 4, and the larger sign is positive, and I have a positive 4.2, so it does check out. Alright, I'm going to let you do B and C, but I'll do E with you, because I know everybody loves a good fraction problem. Ha ha ha. So I'm subtracting 1/3 from both sides. Oh no, we're going to have to subtract fractions. And how do we subtract fractions? It's the same thing as adding a negative fraction. And I hope you remember, because we just finished that in chapter 3, we need a common denominator. So what's a common denominator between 6 and 3? And it's going to be 6. So I need to multiply 3 times 2. So therefore I have to multiply -1 times 2. And that's going to give me 5 over 6 plus a negative 2 over 6. So with a common denominator of 6, 5 plus a negative 2, it's going to give me 3 over 6, which equals 1/2. Okay? So now let's check. 1/3 plus 1/2, does that equal 5/6? So I need a common denominator of 6. So that gives me 2 over 6 plus 3 over 6, and 3 plus 2 is 5, and that is going to check out. Alright, and don't forget word problems. Life's going to come to us in words, so we have to know how to take all of our information and turn it into a math problem. Alright, the Jefferson Memorial in Washington, D.C. is 129 feet tall. This is 30 feet taller than the Lincoln Memorial. Write and solve an equation to find the height of the Lincoln Memorial. Define a variable first. Well, y'all know my favorite variable is x. So let's let x equal the height of the Lincoln Memorial. Okay, because that's what I'm looking for. We're trying to find the it says solve and find the height of the Lincoln Memorial. So that's why I chose to define it as my variable. Alright, what do I know about the Lincoln Memorial? Well, the Jefferson Memorial is 129 feet tall, and that is, 129 is, the word is always means equal. So it's 129 feet tall, and this is 30 feet taller than, so 30 feet more than, there's that word than, whatever comes after than is going to go first. So what comes after than? The Lincoln Memorial. Oh, that's what I named X. So X goes first. So it's 129 feet tall. This is 30 feet taller than the Lincoln Memorial. Now I can solve this equation. I'm going to undo the addition of 30 by subtracting 30. So I have to do the same thing to both sides to keep everything equal. And 129 minus 30 is going to leave us with 99. So how tall is the Lincoln Memorial? 99 feet tall. And also, if you'll notice this last statement that says, remember, we start learning real life application by looking at simple examples. We could have probably solved even this Lincoln Memorial problem solving it by inspection, but soon we are going to have much harder equations, so it's nice to practice with some easy material to help us get ready for the more complicated equations. And that's all I have for today.